Okay, we are live. Yes, we are live. Bom dia a todos, muito bom dia, pessoal. Bom, nós vamos dar início à sessão de palestra do workshop de tese e dissertações de computação. Como a palestra nós temos um palestrante internacional, nós vamos fazer em inglês, ok? So, good morning, everyone. Today I'm very pleased to welcome an international guest in our workshop, Professor Mirco Schoenfeld from Germany. Mirco is the Junior Chair for Data Modeling and Interdisciplinary Knowledge Generation at the University of Bayreuth. Before, he was a postdoctoral researcher at the Bavarian School of Public Policy of Technical University in Munich, and a doctoral candidate at the Mobile and Distributed Systems Group at Ludwig Maximilian University of Munich. He is also a contributor to open source projects. His research interests include data modeling, network analysis, social networks, machine learning, and context awareness. And today, he's going to share his vision about data models. And it's my great pleasure to receive Mirco today. Mirco, on behalf of the organization committee, I'd like to say many thanks. And without further ado, is with you.
Thank you very much, Fabiola, for your kind words. And hello. Somehow I can't see you, but I hope you're there. I learned that you are, well, mostly future PhD students, I guess. You're looking for a relevant topic to conduct your research, or your undergraduates still, following your study programs to finish your computer science program. Anyway, I assume that you are all computer science or all computer scientists, so we're among us. And for people like us in computer science, hopefully at some point our work will have an impact on society, right? So depending on the future that lies ahead of you, maybe you stay in academia and conduct some research in computer science, maybe in artificial intelligence, in machine learning, in data science. Maybe you leave the field of computer science and, like me, conduct interdisciplinary research. Maybe you leave academia in general and work in the industry. Maybe you find a job as a developer, or you're going to manage software teams or something like that. No matter what you're going to do, but it's very likely that your work and our work as computer scientists in general might come in contact with people who are non-experts. Yeah. And much like in this scenario, people with different backgrounds have very different understandings of what the computer does. Yeah, the computer might appear as a complete black box to some people. Yeah, it's for them, or for some, it's entirely unclear what goes on inside, and well, what to expect from the outcome, of an algorithm, of a computer, whatever. For some, these kind of machines are total magic. Yeah. So what I'm going to talk to you about is, well, basically where this kind of misunderstanding maybe is coming from, but more importantly, what consequences are following from this misunderstanding. it's very important to understand that the computer is just a generic placeholder here for many things. Yeah, like the machine that this guy with a hat invented. This can be, well, a computer in general. It can be an algorithm. It can be a machine learning model, some artificial intelligence system, whatever. That's not the point. The point is that it's something from the world of computer science. Okay. Why am I talking after all? Well, I'm also a computer scientist by training. And after my PhD, I stayed in the university and became a professor for, well, data modeling and interdisciplinary knowledge generation. And here in Bayreuth, I'm also the founder of the study program called Data Literacy. So in my daily work, I come in contact with many people who are very, very illiterate in terms of computer, algorithms, machine learning, artificial intelligence, and so on. But of course, they come into contact with that stuff every day, with computers, of course, but for example, via deep learning, what's this OpenAI service called again? Yeah, these large language models where you can generate text. Many of these people come into contact with such systems every day, right? Well, and in my research, I'm concerned with a lot of interdisciplinary work. And I would say my research is best described as something like human-centered data science, right? The fields of research I'm interested in are, well, I'm interested in working with networks a lot. So I do some network embedding, network analysis. I also do some text analysis. And I would say the research data management or the field of research data management is a field where the above come into combination, where they come into contact. And my special take on these fields is context-aware data analysis. Just to give you a slight example, what I'm working on. When I'm talking about context, I'm talking about the fact that, for example, in real-world networks, when we talk about friendship networks, where we could consider these nodes to be people and connections are some kind of friendship relations, then it's very often that we know more, that we have not only the structure, but we know more about these people. We know about their interest. Maybe we have some kind of profile information. All of this can form context information, right? And in my work, I make use of the combination of the structure and the attribute and the context information, for example, to derive some special embedding algorithm, for example, to improve clustering of nodes. In this particular example, we have the related work on the left and our approach on the right, where we can see clear clusters appearing, where we group people based on not only their connection, but also some form of commonalities in terms of context description, right? In the field of research data management, as another very brief example here, we are also working with context. The context information is called metadata here, and we try to obtain more metadata, more context information by deep inspecting the data. So consider a database of a lot of research data, like a text document, like in this case. And we try to obtain new context information about this data item, about this file in the end, by, for example, doing a named entity recognition, by doing some pattern recognition, whatever. So we extract some information from the text that we can then add to our overview of metadata, right? So we already have some metadata about this this file, about this object in our database that might come from manual inspection, from data curation, for example. And then we enrich our knowledge, with the new metadata that we obtain from the content of the files. Why are we doing this? Well, ultimately, we want to help people find relevant stuff quicker. So we use these new context information, these new metadata, to identify connections to other documents in the database, right? And in research data management databases, we typically deal with very heterogeneous data. So we want to link documents across data types, right? So all of our bleeding edge research, is used to help people find more relevant stuff about camels, for example. Yeah, because it was mentioned in the text, because we can see this on the pictures. We are now able to interrelate these items and present to users stuff that is more relevant. Yeah. Something that you might be aware of is knowledge graphs. So from this document metadata structure that you saw earlier, we do that to build knowledge graphs in the end. And on these knowledge graph, we develop rich other services. Yeah. Not only for information retrieval, but also for recommendation purposes or stuff like that. So I know this has been a very, very, very quick ride through my topics of research. If you want to discuss some topics further, please don't hesitate to get in touch. But why I'm telling you this, or why I'm showing you this, is what all of these things have in common. That at the beginning, or at the heart of all these research projects, there is always this very important step of data modeling. Yeah. And that's what we are going to talk about today, or what I want to talk about to you further. So the question is, what is data modeling? I don't know if you had any experience with data analysis so far, maybe in your study program, in terms of or as part of a a practical course, or maybe some data analysis project, or some machine learning project, or maybe in with relation to some coursework. Maybe you classified something, maybe also trained a classification model, maybe you clustered something. And I would be very confident to say that you do this to actually learn something about the real world. Of course, you also want to collect your points for the course. Yeah, I see that. But at some point, you are going to use this data analysis, very generic data analysis pipeline, to find out something about, or to learn something about the real world, right? So you have on the very left, you have an observation in the real world that you want to inspect, that you want to do your research on. So you start collecting your data, and then you create your data model, which is in the very center of this pipeline. Yeah, you apply some computational methods, and then in the end, you obtain some results. Hopefully, they are good results, and you draw your conclusion. And of course, what you want to do is, you want to learn about the real world. Yeah. So what many computer scientists think they do is that they conclude, that they look at the results and actually conclude about the real world, that they can, or that there is a direct connection from their their conclusions, from their findings that come out of a data analysis, that come out of a machine learning model, whatever, that these results say something about the real world. But in fact, these people, these findings, they only describe the data model, right? They don't have an immediate link to the real world, but you just conclude about your data model. The data model was the starting point for your analysis. You did some analysis, some computational methods, and now you're concluding something about your findings. And this is actually about the data model, not about the data or not about the real world. The computational methods, in this case, again, a very generic placeholder. Yeah, it can be some algorithm, some deep learning model, some piece of software, whatever. As soon as you work with some kind of data describing the real world, you have some data model, and whatever comes out of your pipeline is just a conclusion about your data model. Now, this might sound like a very academic point of view. Why is this? Why is this like it is? Because the entire process of data modeling, the entire process on the left of the pipeline, yeah, collecting data and describing the real world in terms of data. All this is the process of data modeling. And it's essentially, or it's basically just a translation from the real world observation to their digital representatives. Okay. And it's very important to understand here that this is a process in which humans decide. So there are human decisions involved. Not only how to present the reality in the computer, but also what to represent, what aspect of reality to represent. Yeah. And the process of data modeling, it ends up in something that, it produces a data model which replaces the reality in the algorithm. And why is this relevant? Well, maybe we can ask what actually is a model, a very generic or a very general definition of models. There are 3 characteristics of every model in the world. Yeah, no matter if it's a model in the computer or if it's a model of something that you can hold in your hands. These 3 key characteristics are the same for all models in the world. Maybe we can think of a race car in a video game. Yeah. So first of all, on the left, there is the original race car, right? With all of its rich characteristics and all of its rich features and whatever. And then the race car in our video game, it is, a representation of the original, apparently, obviously, because we can't have the original race car in our computer. That doesn't work. And the model that we have in our computer, of course, it has only a subset of characteristics, right? It doesn't have all the features that the real world race car has. Even if you have even if you play the most sophisticated simulation game, your race car model will not have all the characteristics of the original. Maybe in terms of aerodynamics, or maybe I don't know. There will be some features that are not are not translated or are not represented in the computer. And the third very important thing is the model is not a model just to have it, but the model has a purpose. Every model in the world has a purpose, and the purpose is to replace the original. So the purpose of the race car in our video game is to let us experience driving around in a race car, right? It's supposed to replace the original race car in our video game. And this arrow, this modeling process, this is where human decisions are involved. This is where selection happening. This is where selection happens. So where the subset of characteristics is identified. This is where human decisions are involved, and this is where individual perspectives are involved. Yeah, just because some guy considers a certain set of features important to have in the model doesn't mean that another person considers the same set of features as important. Voilà. Sorry. Yeah. And now the question is, when we talk about the process of data modeling and the characteristics of a model, why should we even think about this? Yeah, let's have a look at how we are dealing with models in text analysis. This is an example based on text analysis. It should showcase how we can have different perspectives on data and on data models. And the example starts in the library. We have these fantastic ancient books on the shelf. We pick out something from the 15th century, right? And we want to do some text mining on this. Maybe we want to, identify the most important words or whatever. We want to have this as a digital representation and work with it as text data, right? So what are we going to do when we took this book out of the shelf and we open it up? It looks like this. Wonderful. It smells. It has a certain feel. Absolutely amazing. But how do we digitize it? Well, we need to, of course, scan it somehow. These ancient books or these fragile books, or these huge books also, they require certain book scanners, which, do take photos in a very sophisticated way. And now we have an image representation of our book, just like the one that I just showed you. Of course, if we want to work with this in terms of text data, we need to apply some form of optical character recognition to have some digital representation of the text, right? And then we end up with this. You call this a diplomatic representation. So it's just the digital representation of the text. And even if you're not fluent in German, this text is not really readable because there are some characters, that don't appear in today's German, at least. Yeah, some of these might be OCR errors, but some of these are also not not used anymore today. Of course, some people might already have an interest in this representation, but for us, if we want to work further with this textual representation, we need to do more. Yeah. So for us, this is not a proper data model. So we do more modeling. We do more translation. Yeah. In this case, we do some kind of normalization. Yeah. So now we have, a text that looks like regular German text, yeah, that is usable, that is readable. And we can save this in a text file, in a regular text file. Yeah, so we have this really as digital text on our computer. So what is this? This is a data model, right? It's already a representation or a representation of this wonderful, beautiful book that stands on the shelf somewhere. That has just a subset of characteristics, right? Because we can't feel it, we can't see the pictures, we can't smell it, we can't touch the pages, but it can replace the book in our situation, because we don't want to, or we just want to, count words, and we are able to do this based on this textual representation now. Yeah. So, sorry. So, for example, one thing that if we want to go even further, we can do some kind of feature projection. So we further reduce the number of features from the original, and now we have unique normalized tokens. We removed some stop words, we removed punctuation, and so on and so on. And now our beautiful book from the shelf looks just like this, ugly list. Yeah, but this is what we are going to make use of in our text analysis. Or we go even one step further, even a stricter projection, so-called placeholder projection, and we come up to one single placeholder representing the entire original thing, the entire original book. Yeah. So up to now, a lot of data modeling has happened. We have selected a certain set of features. We have translated these features by normalization, by removing stop words. Maybe at some point we have also introduced some errors, during the scan, during OCR, during our normalization, whatever. We end up with this number representing the entire original. And during this process, the data model suddenly changes its role. Yeah, it's not only a description of the data of the real world, but now it turns into some prescription. What does it mean? Suddenly, the data model shapes how we perceive the world. It kind of shapes our vocabulary. It shapes the way we assign meaning to data. It shapes the way how we think about the original. Yeah. Imagine you are going to publish this text data set somewhere on the internet. Yeah. Other researchers downloading that text, the textual representation, they will have no sense for the paper, for its smell, for its look, for its feel. For them, it will be just this list of, or this text file will be just the only access for them to the original. So it kind of is already a prescription of how they are going to see the world. Yeah. And now if we turn this into a more relevant context, rather than just this text mining of books from the 15th century, you may ask, well, who cares? Yeah. Then you can very easily think about these computational methods being some artificial intelligence thingy, some artificial intelligence model that is going to be trained on your data model. The artificial intelligence, it needs to see a range of variety, of diversity of the original, to be able to reflect this variety and diversity in the model in the end. Yeah. And at this exact point, we can have really tremendous unwanted side effects. And that leads us to the question, why should we even care about data models, about data modeling? Well, why is this important? Again, books from the 15th century, really? No. Well, you should care because modeling ultimately leads to bias built into algorithms and built into models. Yeah, because all this data modeling process that I showed you, it requires making some assumptions about reality, about the real world. That's what I called the selection and identification of relevant characteristics before, right? These, in the end, are the assumptions, the simplifications that we need to do to come to a data model that we can actually use. Yeah. But depending on the assumptions that we do, we introduce bias, and this bias is going to build into whatever builds on our data model. That's the issue here. And because we are creating models that impact society in the end, or we create models that represent the original, that hide the original from our access, if you will, we are creating some reality, reality to people who are interacting with our model. It will shape how others see the future, just based on our data model. And well, if you think about it like this, then you suddenly identify highly relevant problems where the machine learning model shows all the bias that is built into it. Yeah. In this case, for example, I think it was Facebook who published this kind of filter, that should make an uploaded picture more beautiful, or the picture of a face. It should, filter the face such that it looks more beautiful. Yeah. But because of this machine learning model being trained on just a fraction of the available diversity in the world, it is only able to repeat that. Yeah. And the result is it just shows what Europeans consider beautiful. Yeah. Narrow nose, maybe smaller lips, lighter skin, stuff like that. Another example. Google Photos released a tagging system for personal photo libraries. Yeah. Another example where the data model, the machine learning model, hasn't seen enough of the diversity of the world. Yeah. So what happened here? This tagging system, it should help assign some textual keywords to these pictures in your personal photo libraries. And it does a lot of things very good. It tags skyscrapers, it tags cars, but there is a picture of people of color who are tagged as gorillas. Yeah. Now you can ask, well, why is this? And why should we computer scientists take care of that? Well, I would argue that the model engineers, the computer scientists behind that, are not really to blame. There is not someone training the system to be racist, right? They don't want to do harm with their model. They have just they don't want to do evil. Yeah. They don't do this on purpose. But maybe the issue was that the development team was just chose their family pictures as training data. And because the development team consisted of just white males in their 20s, there was a certain bias in how the data model was constructed in the very beginning. Yeah. So everything else that was built on top of this data model was really severely flawed. Okay. And this is another example, and well, as sad as it is, it's also one of my favorite examples, because it brutally shows how bias that is manifested into the model can surface at this weird point. So the example is about Finnish. Finnish being a very Finnish is a gender agnostic language. That means Finnish doesn't know gender. It doesn't have pronouns for he and she. It's just everything is the same. Okay. So what you can still try out, if you don't have a Finnish text at hand, you just take a regular English text, translate it into Finnish. That removes all the gender information, and you translate it back to English then. Or you use this example text and use Google Translate, for example, to translate this Finnish text into English text. And what you can see there is that he's a journalist, he's a leader, he works, he is strong, yeah, and she has a headache, she is taking care of the child, she I don't know, cooks meals and stuff like that. So what happens here, the technology that is based on a data model that hasn't seen enough diversity, variety, it just recreates and reinforces very ancient prejudices, biases, discrimination. Yeah. And well, just imagine what that might mean for people to be confronted by technology with the same prejudices, with the same biases, with the same discrimination, just like this. Yeah. And this is one of the examples where the model can influence how people see the world. Yeah, how the model can impact people's lives. And maybe you already thought about it, but another example for where some kind of data model or some kind of machine learning model impacts people's life is one of the most controversial applications of machine learning models, and this is in predictive policing. Maybe you have heard of it. Yeah, that is a machine learning model that is trained on mugshots, and the resulting machine learning model should rate the probability of you being a criminal just by looking at your face. So just by from video surveillance, for example, just by scanning the face, the machine learning model should rate how likely you are going to be a criminal. Yeah? It is a very sensible example where developers might not fully be aware of the consequences of their modeling decisions. Yeah. Maybe in these kind of companies, in these kinds of settings, in these kind of development scenarios, developers are merely not forced, but they have an interest in just looking at, I don't know, improving accuracy of their model, improving, optimizing their model, yeah, without posing critical questions, without thinking about the consequences of their modeling decisions. Because, and now I'm coming to an end with my talk, because I hope I could have shown you that the data modeling, all this process, is more than just improving or data modeling. The purpose of data modeling is not only to improve the accuracy or to optimize the model. Yeah. We as a computer scientists, we also need to ask critical questions, like where does the data come from? Is the data diverse enough? Yeah. Does the data cover all aspects of reality in a sufficient manner? And are these aspects fully represented in our data model? Yeah, these are relevant questions that each and every computer scientist should pose every time. Why? Well, because all these technical design decisions that start in the process of data modeling, they can have ethical implications. They can have severe impact on people's lives. Yeah, and for that, we really need awareness among us computer scientists. All of us, we need to take into account the possible applications of our research, of our models, of the software systems that we are going to build. Well, because it is when our work has some contact with society, yeah, our technical design decisions, they might shape the society's future at some point. And yeah, well, I think it's our obligation to be interested in questions like this, yeah, to, for example, look around in your workplace and ask, is there enough diversity? Is there are all the interests represented to some extent? Yeah. These ethical issues that arise from all of this, they are very complex and they are often not easy to answer. I can't offer answers myself. Yeah, and that's why I just want to raise questions with my talk. And yeah, I want to come to an end now. Keep in mind that you at some point might create realities for people with what you do. Yeah. And so what each and every one of you can do to, well, maybe also overcome hesitations against machines, against computers, against machine learning models, communicate. Yeah. So make your algorithms transparent. Explain what you did. Explain what data you used. Explain your modeling decisions. Provide ways to make your research traceable, recreatable, and explain your work to the public. And with that, I want to thank you for your attention. I'm looking forward to questions and fruitful discussions with you. Thank you very much. Are there any questions?
Okay.
Not very good. Could you please repeat?
Yes. Okay. Thank you, Mirco. Okay. Hi, Mirco.
Yeah, hello. Can you hear me? The connection seemed very very bad for a moment.
But now it's okay. Now it's better.
A little, yeah.
I'm going to a little
Can you read the chat?
Let me try. Just a minute for the audience. We are trying to have some connection problems.
Yeah, I'm sorry.
We can hear you very well.
I'm gonna read some questions from the
Yes.
public.
Thank you. Mhm.
Heitor Freitas says, do you think there is enough financial incentive from the big techs developing this kind of algorithm to consider the case of the models that you described?
That's a great question. Yeah. Yeah, I think. I mean, it's not about a certain type of models that I want to train, right? But maybe it's about thinking about the structure of how maybe I don't know, incentives among development teams are created, right? Maybe it's not all about improving accuracy up to, I don't know, squenching out every percent that it's in there. But maybe it's also a matter of, thinking about the kind of performance indicators, right? Maybe it's not just a matter of accuracy for a machine learning model, but maybe there are also other factors that mark a successful model. Yeah, like for example, explainability. There are many examples, especially in healthcare, where, for example, development teams try to train machine learning models that, given a patient record, should predict the disease and predict also maybe some kind of medication. Yeah, and there are many examples where these development teams specifically said, okay, we don't use. It really decided against neural networks, for example. We don't use any deep learning model, but we rather stick with our very basic decision tree, yeah, which might be 3% worse, but it is explainable. We are able to understand what this model is doing. We are able to understand classification decisions, or the outcome of things. We are also able to understand the architecture of the model. What kind of indicators did the model pick up? Yeah, maybe things like this, examples like this are also important to consider, which are other performance indicators, basically.
Okay, can you hear me now?
Yes, much better. Thank you. Whatever you did.
Thank you, René. So, one more question. I'd like to know, does it make sense to add complex information in a model? I mean, are the data models mentioned, they exactly what the book, or we can add some content.
Yeah, well, that depends on what kind of, that depends on the design of our data model, right? I mean, this was a very simple example where we just wanted to have access to the text. If we need some access to context information like metadata or something, then we just design more complex structure than just a list of words, but maybe some kind of key value store, yeah, where we have some fields for metadata, some fields for text, and then we can add a lot of information in there. But it's rather the application or the depending on the purpose what you're going to do. Yeah, I mean, if you select an algorithm for text analysis, you will most likely throw away all the context information anyway and just work with parts of the data model. But of course, you can design your data model as complex as you want. Sure.
Okay, thank you, Mirco. One more question. I've been thinking a technical question, right? How can we store or handle a model? We can imagine a model in a concrete database or something like this, or there isn't some directions to store and handle data models.
So if I told you about how I store my data models for my research, you will most probably I would say that depends very much on that depends on a lot of things, you know. I mean, if you do your research at your computer for a paper, for your master thesis, for whatever, you will most likely have some structure that is very pragmatic, that is very easy for you to handle. May it be an SQLite database, may it be just a bunch of. So I mean, I'm using Linux a lot. I love just using text files, yeah, for text data. I love using text files also for relational data, like CSV files, for example. Yeah, I work a lot with them because it's very easy for me to handle with the Linux tools. Search and replace. You can aggregate information and stuff like that. You can even load it into R, into Python, into whatever programming language you're familiar with, and so on. Yeah. As soon as you want to publish your work, or that might look a little different. Yeah. of course, you can. I mean, I've published data sets where we still stick to some kind of CSV file, some kind of text file. Yeah. The very, very important benefit for that is that everyone on the world, every computer on the world, can open it. Yeah. I mean, if you send around an Excel file or if you send around an open document type kind of thing, yeah, there are, I guess, 90% of your collaborators complaining that they can't open this certain file that you send around. No matter what kind of data format you're going to use, you still need to explain how to handle your data file or how to handle your data structure. Yeah, you need to have a code book where you explain the fields of your table, where you explain how the data was created, where you explain what certain values in your fields mean. That is very important. Some modeling decisions, for example, when you have your database of ancient books, and for some reason you don't have a text available, what do you enter into that field? Do you leave it empty? Do you say it's null? Do you say that's not available? You know, you need to make that transparent, what this means. Do you, I don't know, do you enter 42 in that field? Yeah. But it's very important that you write that down somewhere if you want to publish it. And not only if you want to publish it, you do your future self also a very large favor if you write that down somewhere, because well, we all know how it is.
Okay. Yeah. One more question, Mirco. Is there some way to imagine how can we evaluate our data models? Is there some way to evaluate before to submit to machine learning, or is there some way to evaluate how good are our models?
That is a very good question, and also a very complex one. And I think that I think that's a point where we computer scientists mustn't be left alone. If we train some machine learning model for, I don't know, healthcare application, photo classification, whatever, it's very important that we communicate, and that we communicate with experts in the field. I think there is no one single indicator that we can use to measure the quality of our data model, because the chain of modeling decisions and their consequences on the outcome, on the result, on the possible conclusions that we are allowed to draw in the end, it's so complex, and it's so delicate. I think there is no performance indicator for that. I think that can only be tackled by putting together computer scientists with experts in the field. Both sides need to explain each other what they are doing, what consequences of certain design decisions might have. I think communication is key.
Yeah. So we could pass hours and hours talking data models, right? I'd like to say sorry for connection problems. I'd like to say thanks. That was a very good presentation, very didactic, with a foundation topic and necessary topic. And I'd like to ask you to say some last words to our students. Do you have some tips, some advice for our graduate students in a generic way, please?
I can only speak from my experience. For me, it was a great experience to enter this field of interdisciplinary settings, where it's not about improving accuracy and stuff like that, but to be forced to explain the consequences of what you're doing, explain the application, explain the meaning of things that you're doing. That is still a challenge for me, and I can recommend it to everyone. Do it. It's really fun. It challenges you, and it's really fun.
Okay, thank you very much, Mirco. It was a big pleasure. Thank you for all the audience. I can now stop the stream.